So really quickly, my name is Cornelia Davis. I am the Director of Platform Engineering for Cloud Foundry, so I'm at Pivotal. I have been working with, I just realized it's September already, I've been working with Cloud Foundry for about 3 years. I came to Pivotal from EMC, where I worked in the corporate CTO office, and we did emerging tech there. And about 3 years ago, I was rolling off of a project, and my boss, Tom McGuire, at the time said, hey, I want you to start looking at this new thing called PaaS, relatively new. And so I started looking into that, and of course, we were EMC, and Cloud Foundry was VMware, so I started looking at Cloud Foundry then. And about a year ago, I joined the Cloud Foundry team proper in this platform engineering role. Platform engineering is a very small engineering group. We're in the product team, but we're field-facing. So I spend virtually all of my time working with large strategic customers as well as partners, kind of pushing the envelope with Cloud Foundry. So definitely hands-on technical. And so you'll hear a lot of the kind of reflections throughout the talk on that. And introducing also my colleague Josh Kruk, who works with me at Pivotal. Go ahead.
I'm Josh Kruk. I work on the sister team to Cornelia's in the customer success office. My role is 50% customer facing, helping people be successful with Cloud Foundry. So that's deployment and operations, and then also a lot of app development. How do you transition your apps, or how do you write new apps to take advantage of kind of the third platform? And then the other half of my time is also spent focused in product. My passion is kind of utilities and tooling around Cloud Foundry and making apps that work on the platform or against the platform itself for operations.
Awesome, thank you. All right, so what we want to talk about this morning is you've already heard tons and tons of the phrase cloud native, and you've probably also heard people talk about 12-factor apps. And the short of it is that the way that we used to build applications in the last couple of decades was really optimized for the architectures that we had back then. And now the architectures fundamentally are different. So to give you a little bit of a perspective, I've been doing this for a long time. I'm going to date myself here, but I've been writing software for 25 years. And when I first started, I started in embedded systems, and I wrote code in C or even Ada. I was in the defense industry. And the most sophisticated thing that we did was we cross-compiled. So I compiled on one machine and took the binaries and ran them on another machine. So there was nothing that was inherently distributed. And I also remember we actually had one project where we had 3 processors. And we actually had a whiteboard that we drew out what was happening on the different processors and how we timed out how long things were going to take and where the handoffs were going to be. It was very static, and it was very, very rigid. And now everything's distributed, right? So these cell phones that we have didn't even exist. The cloud didn't exist. And so the way that we built applications in the past was for the architectures that we had. And the architectures have fundamentally changed to be cloud. Now, we'll talk about what exactly does that mean in just a moment. But because the underlying architectures have changed, everything is distributed now. Everything is always changing. That old diagram with very rigid timings and so on, that would just never fly in this world. That fundamentally means that in order to take advantage of that architecture, we need to change the way that we build our applications. So you've heard about this thing called 12-factor perhaps, but what we want to do is really kind of demystify that a little bit in this talk. Get very concrete and say, what are those 12 factors? Let's look at them, let's understand them a little bit, think a little bit more deeply about them. And by the way, even in an hour-and-a-half talk, we can't talk about them and think about them as deeply as we should. So hopefully what I'd like you all to take away from this is I really need to study these things. I have an introduction now. I need to study these various factors and understand what they are and importantly why they're important. Because that's going to be what enables you to build your applications the right way and honestly be able to articulate it to your colleagues who are not here at Spring One. So that's really our goal, is to get you understanding those things and thinking more deeply about them. So what the heck is a cloud native application? So there's whole bunches of definitions and attributes that people associate with cloud native applications, and everybody's got a different definition. So I've pulled a couple of them off here. So one of them that I found, it was actually a quote, which is why it's in quotes, is developed specifically for cloud platforms. And I'm like, okay, so what's a cloud platform? That's like looking something up in the dictionary, and they say, you know, I don't know, I should have had a better example off the tip of my tongue, but you know, you go to look up a word, and it says, oh, that's in the business of, and they give you this shortened version of that word. So it doesn't tell me anything. So what is a cloud platform? Is it AWS? Is it Cloud Foundry? Not sure. It's highly scalable. Absolutely, no question. And high scalability, really almost what I'm thinking there is as soon as you have more than one machine, that's already scalable. You already have to deal with some level of distribution. And in many cases, it's very highly scalable. So that seems about right. Mobile, yeah, not always, but probably a good idea. And we'll talk a little bit about if you've got multiple devices that you're supporting, what's one of the factors that you might think about there? Agile, definitely. Definitely in this world, we are constantly releasing software. We need to have agility, not only agility in the software that we're releasing, but we need to have agility because the platform that I'm running on is always, always changing. And we'll talk about that later in the talk in more detail. Applications that run in containers, well, actually, I think that's an implementation detail. It really doesn't matter. We have things that are out there running, whether they run in containers or not. Really, I don't think that that's part of the definition of cloud native applications. Microservices, Josh was teasing me this morning. We almost made it through the entire talk without putting the word microservices on the slide, but I snuck it in late last night. So here it is, microservices, probably. And again, we could go off and do a definition around microservices. Designed for failure, without question. That's what I was just talking about. Things are always changing, and we'll talk a little bit more about design for failure. So the other part of the title, so I've been talking about cloud native in the first slide, but if you remember that the title of the talk had 12-factor in it as well. So 12factor.net, if you haven't looked at it, there's the URL. Definitely worth a read. It's pretty short. Actually, it's quite short. And it talks about, it was written by a number of developers that worked at Heroku. So Heroku was a platform as a service out there, and people have been deploying apps onto it. And they kind of figured out what some of these patterns were, some of these factors were. And so we're starting with the 12-factor, but you'll see that we're actually going to go a little bit beyond that as well. So 12-factor is just a really great kind of concise description of what some of these factors are. So we're going to use that as kind of our guide. I'm not big on agenda slides, but you can really think of 12factor.net as kind of the agenda that we're going to go through. Now, the first factor then is Codebase. And you can see the subtitle there says, one Codebase tracked and revision control, many deploys. So obviously, we need revision control. So we're not going to focus on that part of it. That's just table stakes. But there's a bigger question. And by the way, we're going to spend a lot of time not only going through slides, actually that'll be the smaller portion, is we're going to spend a lot of time inside of GitHub and inside of the code, and we're going to do lots and lots of demos, if the demo gods will have it. So if you read the first factor, it really is talking more about, like I said, repos or table stakes, but how are you breaking up your code base? That's really the fundamental question there. And they make the assertion that one code base equals one app. Now that seems relatively straightforward, although you can imagine now that, well, wait a minute, what if I have a large complex system and it's really a composite application? You could say, okay, I've got a composite application and that's made up of a whole bunch of apps, and we're going to do a one-for-one mapping on that. But really, that's what this first factor is challenging. That first factor is getting you to think about how do you break up your code into different repositories. And the interesting thing is that there's actually an organizational design question in there as well. It seems like it's super straightforward, but you can spend a lot of time just thinking about this. So really the question is, this mapping of one code base to one app, is that really the way it goes? And the answer is maybe. And let me take a moment here and say something that I wanted to emphasize early on. So these 12 factors are not hard and fast rules. It is not that unless you follow all 12 of them to the letter, and by the way, it's so short that there's room for lots of interpretation in there, you don't have to follow all 12 to the letter 100% before you have a cloud native application. So you should take a look at each one of these and really, like I said, think deeply about it and think about what it means in terms of your particular deployments. So again, the question is here, and the answer is maybe. So let's look at some alternatives. So I'm going to kind of do a bit of a proof here and say, well, I want to prove one code base equals one app. So let's look at some other things and basically show conflict. So let's take a look at a couple of these, because really it comes down to that's probably a pretty good rule. One code base equals one app. So let's look at those alternatives. So this is something that we have done in the past, is one code base equals a whole lot of apps. Now, we did package things up in monoliths. So you could, in fact, and you probably thought of it, that middle thing there, the application, as a single application. But the reality is that you should be breaking that monolith up. And I spend a lot of time with very large clients who that's their biggest question, is I've got these legacy monoliths, and I know I'm having all this pain around it because it's hard to rev, and it's hard to even get a team to be able to grok what's in that monolith and start being effective on building code and so on. So they know what they want to break these things up. So rather than asking the question of one code base equals many apps, it's really one code base for what should be many apps. Now, of course, this here is an anti-pattern. We are working away from the monoliths. The other thing that I'll tell you in working with customers is we sometimes have customers that say, okay, I want to try out Cloud Foundry, and I want to take an existing app, and you know what? How about Documentum? Or how about LifeRay? Could I run that on your platform? And the answer is no, 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 no. Cloud native doesn't mean you take the existing, all of the legacy baggage with you over into the cloud. Cloud native means that you're getting rid of some of that baggage. So this is really an anti-pattern. But it's something that we can migrate from, and like I said, a lot of customers are working from that. So this one let's put this one off to the side. When it comes to migration, I'm just going to make a couple of comments here. We have a couple of talks that we'll reference at the end of the slides, and other talks here at Spring One. This one, Migrating the Monolith, unfortunately already passed. How many people made it to Rohit's talk yesterday? A handful of you, that's great. So Rohit spoke yesterday afternoon on Migrating the Monolith. The good news is that all of these are being recorded. So I would encourage you to go back and take a look at that one once the recordings are made available. But really, when it comes to migration, there's some patterns that we can follow. So there's some prerequisites. You want to make sure you have adequate test coverage and pipelines and a sane build environment. Then you want to choose things very carefully. What do I want to pull out of the monolith? Make sure that you can demonstrate value in the extraction. You extract the thing. Now, here's the key. When you extract that component, what you're doing now is you're creating a separate app. A separate app that's maybe its own repository, or that has to be its own repository. So now you're moving back toward that one-for-one mapping. And then you can do things like put proxy patterns in place inside of the monolith. So that's just a really quick high overview of the migrating the monolith. And so on this first one, we kind of get back to, okay, maybe it is that one-for-one mapping. There we go, new repository, circling the emphasis that I made. Well, what about a lot of code bases equaling one application? Let's look at a scenario here. This was actually one that was brought up when we were talking about this with a colleague of ours, Josh McKenty. And he suggested that perhaps you might have a single code base that has two different processes running in it that are going to get deployed as two different apps. So for example, here you've got a web interface that is accessing something that's maybe in queuing work. So I'm scheduling a doctor's appointment, and now I want to queue up something that says, before I get to that doctor's appointment, please make sure that you've transferred all of my medical records from the cloud down to the doctor's office, the local doctor's office. So the little gray box and the little green box, those are the two different apps. And could we say that that's a single code base that really is just one app but two different processes? So let's suspend disbelief for a moment and think about that. So maybe that's a decent scenario. So I've got these two different apps. But if you start to think about it, if you've got, we were talking about here about having two different code bases, two different repositories, single app. But if you've got two different repositories, you're probably talking about two different teams. Or you're enabling two different teams to work on those, two different pizza box teams, right? And as soon as you have two teams, you probably want an API. Because in order for two different teams to work on things, turns out that interfaces are a really great way of thinking about organizing your development teams. So if you can put an API there, then you can separate out your development teams, which means you can scale your development. So that's factor one, code base. So we come back to the question of one code base equals one app. Yep, probably. That's probably a good idea. So let's do a little bit of an aside here. We talked about the fact that we were going to talk about 12, and now I will let you know that that's not all. We're actually going to talk about a number of other factors that we think are important as well. So here's one of the first bonus factors. By the way, you'll notice that we're not going to go through the factors in order, so from 1 through 12. We're going to go through them in an order that seems to make a bit more sense to us. So here's a bonus factor, and that is when you're designing your applications, think about API first. Think about the interfaces, how your microservices, there it is again. Microservices was there before. Think about designing them, even developing those APIs first. So one of the great things that you can do, and one of the things that you can do to enable testability, is to create implementations of your APIs that are mocks. So in order to be able to do testing in a highly distributed environment, you need to have mocks of different APIs and different services. So even developing, even before you put the real implementation back there, you can develop mocks for your APIs. You need to version your APIs, you need to be able to discover the APIs, and so on. So there's a whole community out there that's really involved in API development and API management. And you can see there's a URL that's apifirst.com. So have a look there, really, really good information. All right. Factor number 2 says dependencies. Explicitly declare and isolate dependencies. So the first thing that I want to say is you need to ask the question of why. Because that's really what's motivating it. So why are we doing this? Well, clearly we're all developers. It's really to make our lives easier, right? It's all about us. And I'm a career-long developer here, so I include myself in there. So it's all about the developer avoiding dependency hell, right? So, and I know that Spring 1 is a developer conference. I go to other conferences like DevOps Days where it's completely skewed the other way, where it's a room full of operations folks. And I realize that most of you are probably developers. But eventually, your apps will hopefully, if they see the light of day, be operated by you in production. So it's not only about making our developers' lives easier, but it's also about making operations' lives easier. And one of the things that we absolutely have to have on the operations side is repeatable deployments. If I cannot repeatably deploy, or if I cannot deploy throughout the entire application life cycle without huge hurdles coming up, then that's really going to stymie my ability to be very agile in this new world. So let's take a little detour for a moment and talk about that in a bit more depth. So I'm going to jump over to factor 5. I'll come back to factor 2 in just a moment. So factor 5 says strictly separate those different stages in the application. Strictly separate. Factor 5 in 12-factor actually talks about build, release, and run. What we like to do is we like to add the design phase as well. Now, I want to take just a moment here to talk about those different phases and talk about who's doing those, what you're doing, and then why don't we want to merge that with some of the other phases? Why do we want to create this strict separation? So first of all, design, that's most of us in the room here. Developers are using things like Spring and Spring Boot, Gradle, and Maven to be able to express those dependencies. Why is the developer doing that? Because the developer best understands the application and understands the dependencies. So that one's pretty straightforward. Build. So first of all, the notion here is that you need to create a build and you need to create a deployable artifact that is the artifact that runs through the rest of your application lifecycle. So we all know the stories about it works on my machine, it doesn't work on my machine. And if you are changing builds, then the build environment could potentially be the problem. So where is the problem? We don't know. So one of the ways that we can minimize the different places to have to look for the problem is we say, we're going to do builds in one place, and then that's going to be the completely automated and repeatable way of doing builds. That, in general, is going to be your CI system. If you don't have a CI system, you absolutely need to get one in place. There is no way that you can build software in this new world with a CI system. So what you're going to do here at Spring 1, of course, you're going to create a war or a jar file. And the whole point is one build, many deploys, and gets away from the anti-works on my machine type of response. Then you're going to create a release. Now, who's going to create the release? We believe it is the platform. So let me take a moment here. The title talked about for Spring developers. We're going to give you lots of examples of things that are available in Spring, but you notice that both of us are on the Cloud Foundry team. We believe that a lot of the things that are necessary in 12-factor are not only satisfied by the development framework and the language, but can be best satisfied by tooling, i.e. platform. I already gave you the one example, a CI system. Other cloud platforms can satisfy those other things. So for a release, what we mean is, okay, let's take all of those code bits and glue it together with the rest of what we need. What's the rest of what we need? Well, it might be the JDK. It might be an application server. It might be the base operating system that you're running on. So we need to glue those pieces together into something that we call a release. That release is something that we can then deploy. It's something we can version. It's something we can roll back to, and so on. So this is all about agility and, like I said, those upgrades and rollbacks. And then finally, I want to be able to take that release and run it. And there, again, the platform is all about, the platform satisfies taking the release and running it. And there, it's all about speed. And you'll see that later on as we go through some of the demos. All right, I'm going to go ahead and skip this deployment pipeline. It'll be in the slides, which we'll put up on SlideShare. But now let's go back to dependencies for a moment. So remember that it's all about repeatable deployments. So the punchline here is that you should never assume anything about the environment that isn't entirely automated. So you need to explicitly declare the dependencies. But then you can ask the question of that runtime, eventually there's the runtime environment. There's the operating system, there's the JDK, there's the application container, and so on. Who's going to specify that? Is that going to be the developer or the platform? And what we're going to do now, finally, thank you for your patience, is move out of PowerPoint and take a look at some code. So I'm going to check my clock, and I'm running super slow, so let's get going here. Okay, So let's take a look at the code. The URL will be on the final slide here as well. Everything that we're going through here, all of the samples are available in this GitHub repository, so you can take a look at that. But what we have here is a GitHub repository that has lots of branches. So you can see that we've created branches for all of the different factors. And again, we're not going to go through them necessarily all in order. We're going to start here with the F2 dependencies branch. Now this branch is exactly, if you go to, this is going to be a Spring Boot app. If you go to the spring.io starter page, this is the Spring Boot starter app. It's exactly that. And you'll see if you look inside of the code to take a look at that. Now let me come over here, and we are in F1 Codebase. So again, we can see that you can see all of the branches. Here, let me get all of the screen real estate that I need. So I'm going to do a git checkout. Oh, we're off the bottom of the screen. So let me scroll that back up. How's that? A little more. I don't even get all the screen real estate. No, a little more. There we go. Okay. F2. Okay. Absolutely. So I'll scroll it down so you can take a look at it now. There we go. So it's GitHub cdavisafc/12-factor app. Okay, and we will give you that URL's on the last slide as well. Okay, so here we've got F2 dependencies, and I'm going to go ahead and do a build on this. Okay, so like I said, this is just the standard Spring Boot app, and I'm going to deploy this to the platform. So let me do a CF target and make sure that I'm in the right place. Okay, there I am. I've got my space. And so I'm going to do a CF push, and I'm going to point to the jar file, because I built a jar file, and then, hello, 12-factor. Now, the main thing that I want to show you here, so this is not a talk about Cloud Foundry per se, except that, like I said, some of these factors are best realized by a platform. And so what we're doing here is, you'll notice that I've just supplied the jar. I did not supply a JDK. I did not supply an application container, or did I? We'll talk about that in just a moment. And what you see here is you actually see, remember that factor 5 that we went off on, and we talked about design, build, release, and run. What you see right here on the screen right now is you see the platform producing a release. Remember I said that the release is where we take the WAR file or the jar file, and let me scroll up a little bit here. A release is where we take the code, the WAR or the jar file, and glue it together with all of the other stuff that's needed to just run it. So it's glued together with the JDK and the application container. So if we take a look here, you'll notice that it recognized that it was a Java app, and it grabbed the JDK. So grab JDK 1.8. And then it went ahead and it did the rest of it. And now you can see that it is, in fact, running right there. Greetings from Spring Boot. So the app is running. Now, you'll notice that it just pulled in the JDK. And that is because, as you know, Spring Boot says, no, we're not going to use excuse me, no, we're not going to use an external application server. We're actually going to bundle that as a part of the jar itself. So when we run that jar, it has an embedded Tomcat inside of it, and that's what started up. Now, you might say, well, really, and in the past, if you know anything about Cloud Foundry, in the past, before Spring Boot, the platform brought the application container. It brought Tomcat. So you can ask the question of, well, what's the right way of doing things? And those that are very enthusiastic about Spring Boot will say, oh, you always bring the application container as part of Spring Boot. It's always part of the application. But I can tell you from working with customers in regulated industries that one of the things that they like is they say, you know what, we need to have some control over what that application container is. We, IT, are only going to provide certain application containers. So we don't want the developer to make that choice. We want to make that choice. Now, there's a number of different ways to crack that nut, but what I'm going to show you here by switching to a different Git repository is I'm going to do a git checkout, F2, and I'm going to grab the other branch. So there's another branch there. Let me go ahead and do a build on that and do a push, and I'll show you the difference. If I could type, that would be great. So we'll go ahead and do the build, and then I'm going to push that app again. There we go. And you'll see the difference in that release process for a moment. But the whole point here that you're going to see very, very clearly is that we go through that release process. So again, it's uploaded or uploading, yeah, it's uploaded the application, and now we're going to go through that process of generating that release. And here we go. You'll notice here that it grabbed the JRE, but it also grabbed, it did not grab, I know what the issue is. I pushed the jar, not the war. Exactly. Thank you very much. So we'll go ahead and kill this. So let me show you that. So in the libs directory, the first time that we built the jar. But when I built the other way, and all of this is in GitHub, you can see the difference in the Gradle build file. So the Gradle build file was the only difference from F2 with the embedded to F2 with the external Tomcat. No changes in the code, none at all. It was just a difference in the build. And you'll see that what we do instead is we build a war file. And so instead of pushing the jar file, which of course I got the same thing, let's go ahead and push the war file. And now you'll see the difference. Now you'll notice, by the way, that there's this 12-factor jar.original, and that's because the Gradle plugin for Spring Boot, so there's the Gradle plugin for the jar is sophisticated enough that when it came to creating the Gradle plugin for Spring Boot, they didn't want to repeat everything that was in the Gradle plugin for jar. So the way that the Spring Boot Gradle plugin works is it uses the Spring Boot jar, uses the jar Gradle plugin, takes the output of that, which is that original that you see, and then applies the other plugin to that jar file. So that's why you saw the two jar files in the build directory. And so now you can see here that, in fact, it did grab the JRE, but then it also grabbed Tomcat. So you can see here, downloading Tomcat, expanding Tomcat, and so on. So again, the difference is really only in the build file. Okay. All right, so let's go back into our code. And this right here is a picture of the different layers. So when you're deploying an application into the platform, you see that big dotted line. Remember I said the container's an implementation detail? It really is. But that is the container, and that's all the stuff that's running in the container. You've got the host operating system, but then you've got the OS image that's running inside of the container. Then you've got that runtime layer, which is Tomcat, the JDK, and maybe some other stuff, and then you've got the application at the top. And the question there, again, is that runtime layer. And you'll see that there are pros and cons, and later on when Josh is talking, you'll see that one of the values of having this layered separation is that it allows something like a platform team to rev things at the lower layers, at the blue layers in this diagram, and allows the application teams really to stay up in the application world. So you don't have to have things so tightly coupled anymore. All right. So this is really just the code that's the difference. This is the embedded runtime, and here's the external runtime. You do have to explicitly not use the Spring Boot plugin, Gradle plugin, because that will always bring in Tomcat. So you have to kind of dissect it a little bit and instead bring in just this plugin here, this dependency management plugin, and specify your dependencies down here. So all of that is available in the GitHub repository. All right, so 2 more factors that I'm going to talk about, and then I'm going to hand it over to Josh. So factor number 3 says configuration. So what you want to do is store the configuration in the environment. So first, let's talk about what is configuration. So configuration is going to be things like handles to external services, to databases, those types of things. Credentials, for example, per deploy values. So maybe some URLs that are specific to your prod deploy versus your staging deploy. Really anything that is going to differ as you go through the product, the application lifecycle. Anything that's going to be different from dev to test to prod, all of that needs to be in a configuration. Now, we've stored these things historically in a number of different places. We have stored them inside of the code, and I thank my colleague Matt Stein for the Captain Obvious parenthetical remark here. Yeah, you should not be hard coding things in your code, but how many people here have code bases where there's probably configuration hard-coded, right? We all do. It's not just you. Property files. Don't put them in property files. What? Wait a minute. Isn't that what I'm supposed to do? And you'll see an example of that in just a bit. So the answer is, generally, you're going to be checking things into, you're going to be checking the property files into your source code control system. And so you don't want things like credentials in there. So property files are generally not a good thing. The other thing is that property files are almost always built into the jar or the war file. And remember I said that one rule is that you're not going to do a new build per stage in the life cycle. You're going to do one build, many deploys. That's another one of the factors. That's the next one we talked about. Or in the application server. So where are we going to store it? Well, we're going to store it in the environment. So let's have a look at that. Let's jump back over into our code, and I'm going to do check out another branch. Environment config. And what we have in here is that same application, but now I'm going to parameterize it with an environment variable. So let me go ahead and do a build on this. And then we'll go ahead and deploy. And while we're deploying, I'll take a look at the code. So I'm going to push, and I'm actually going to go back to my jar file because I'm going to do everything in the embedded app now. So if I come over here while we're letting that deploy, and I'm going to, I know that you can't see, the URL at the top isn't that important anymore. So let's come over here and go into the environment configuration. So what I've done now is I have changed it. I've changed my controller. Is that big enough? Probably not. How's that better? Okay, so the key lines that we're looking at here is this is super simple. We're going to put things in the environment variables. Now, how things get into the environment variables, that's a whole nother discussion. So how we get things into those environment variables, and in fact, you'll see some of that when Josh talks about some of the other factors in just a moment. But assuming that we've gotten things in the environment variables, what do I do as an application developer? Well, I'm just going to use something that's available in Spring. So Spring gives me these libraries that allow me to get into the environment variables very quickly. I implement environment aware. You can see here that I'm grabbing those environment variables. So here's the environment variable that I'm interested in. It's something called who, and then I change the greeting. So in the meantime, this should have deployed, and in fact it did. So if I curl this again, you can see greetings null. So the environment variable hasn't been set. Now, the environment variable, of course, is in the container that's up in the cloud. So how do I get things up in the cloud? Well, Cloud Foundry has a nice little command called setenv that allows you to, this is a different one, we'll get to that in just a moment, that allows me to set an environment variable to a value. And then what I need to do is it says CF restage, but I'm actually going to do a restart, and I'll explain that in just a moment. That's going to restart the app. Now, a restage says I'm going to create a new release. In this particular case, I know that my code is looking the environment variables up at startup time. It's not using those environment variables at release generation time. If it had used those environment variables at release generation time, then I would have had to do a restage. But in this case, I didn't need to create a new release because that environment variable only affected the runtime behavior. So now, if I go into and curl this, you can say, see, it says, greetings, Josh, from Spring Boot. So store the environment, store the configuration in the environment. All right. One more factor, and then we'll hand it over to Josh for a bit. So there's some code for picking up the environment variables. All right, so now we're going to go. We started with factor 1, factor 2. We went off to factor 5, came back to factor 2. Now we did 3. Now we're going to jump all the way ahead to factor 11, which is logs. So one of the things, of course, that you need is you need to be able to read the logs. Now your applications are deployed out into the cloud, and I need to be able to get those log messages. So how am I going to do that? And the answer is that just like environment variables are kind of a ubiquitous thing that exists in all operating systems that are accessible by all languages, it's kind of a de facto standard. There's another de facto standard that is available here on the log side, and that is just send things to standard out and standard error. So if you're sending your log files to some special log file somewhere in some directory, then whatever environment is streaming those logs for you is going to have to know about that directory. Or if you're going to write your log files, your log data into some database, then the system would have to know about getting the logs from that database. And so the thing that the platform can do is if we just say, look, just send things to standard out and standard error, then the platform says, I'll take it from there. I'll just go ahead and grab those things. So that's really the thing to do. And so let's have a look at that. So if we come back over here, I'm going to do a git checkout, F11, and I'm going to go ahead and do my build, and the build will happen very quickly, and then while it's deploying, we'll go over and take a look at the code. So there's my push. All right. So let's come over here and take a look at the code while that's pushing. Go into my F11 branch. There it is. Into logs. The main change in the application here is that I've, of course, added all of the standard stuff. So if I come down here into main and into hello, you can see in the controller that I've added the logger stuff. And here you can see that I've added the logger stuff, and I've added a debug message, so log debug, and there's some other log info stuff over on the application side on the startup. So that's the pretty straightforward stuff. And that's all fine and good, but we wanted to take it one step further. So when you're doing logging, you're going to have different levels. Info, debug, all of that stuff. You're going to have those different levels. So wouldn't it be great if I could control those levels without having to do a rebuild somewhere? Okay, and the answer is you absolutely can. So if we come down inside of here, you'll notice that we've added a resources directory. And in here, we have an application.yaml file. And that application.yaml file identifies and actually defines values for those properties that the logging packages are looking at. So that logging package is looking at the property logging.level. And then which package. So you get to set the logging level for each of the packages individually. So this is a place where you can define those things. But wait a minute. Didn't I just tell you in the very previous one that you shouldn't have things, that you should configure things in the environment, not in property files? Isn't this just a property file? And the answer is yes. However, this property file, the only thing that we're using it for is we're using it to be able to have a tree structure to my properties. So those log packages are expecting this particular tree structure for the properties. And you'll notice that what this syntax does right here, this syntax, is it defines a default value of info, but it says look up the actual value from an environment variable. So I'm right back to environment variables right here. Okay? So let's go over and have a look. This built just fine. And in fact, let me, in a new window, do a, oh, and I meant to check this. This is the big drum roll. Do we have a proxy in place? CF logs, CF, yep, that's the one. CF apps, oh. Okay, so this is tailing logs, so that's a good sign. So if I now curl this endpoint, greetings, Josh, and drum roll, there we go, we're getting some output. But one of the things you'll notice is, first of all, I didn't get the I intend to greet someone. And that's because by default, my log level is set to info. We'll show you how to set that in just a moment. But you'll notice that I got some log output anyway. And this, in fact, is log output that the platform is providing. It's not application log. It's actually something about the context that the application's running in. So this shows that a message got routed to my application. So let's come back over here, and I'm going to do that set env again. And I'm now going to set that log level to debug. And I'm going to do a CF restart. There we go. And that should only take just a moment. And then we'll curl it again. And by the way, you can see all of the log information that's coming out here on restart. If we had more time, I would go through this. It's extraordinarily interesting to see what the platform is doing on your behalf as you do a restart in this application. So you can see here that there's some DEA messages. There's some API messages if we look up here. And then you can see that there was a whole bunch of, and in fact, there's the Spring Boot logo should be popping up here somewhere. It's a whole bunch of info messages that are coming out. Wow, a lot. Okay, and now the application started. Let's go ahead and curl it. And we should see over here in just a moment. There we go. I intend to greet someone. So that was the debug message. So again, you can see how we controlled that through environment variables. Okay, so let's come back over here and go back into the slides. And there is just really the punchline. I like to, even though we did live demo, I like to have those in the slides for your cheat sheets later on. And I see somebody taking a photo, so I'll let you take your photo, and then we'll move on. Okay. So I'm going to hand it over to Josh, who's going to go through a whole bunch more factors. Yes, question?
Question on logging. Finding all logs to basically standard error and standard out. Do you have a tool that lets you, that you prefer that parsing of that?
Yeah, in fact, you'll notice that so the question, to repeat the question, if you're putting everything to standard out and standard error, do we have a favorite tool that we use to basically parse out of that? And the answer is absolutely. So you'll notice that when I did the CF logs space app name, I've already taken everything and pared it down to just the app. So I've got platform logs and things like that. But it was only platform messages that pertained to the application. So there's actually things built into Cloud Foundry that allow you to scope your logs to the application. So that's number one. Then the next thing is, well, now I've got a whole bunch of log information in there. How do I parse through that? We actually use a number of different tools ourselves when we're operating our applications in production. We use things like, we might use like Logstash or Splunk. The other thing is that Cloud Foundry partners with a company that uses an ELK solution that allows you to pipe those logs into an ELK Kibana environment and then do all sorts of, I can show you some really, really cool dashboards that are built in on that as well. So the answer is that there's plenty of stuff built into the Cloud Foundry platform, and then you might also integrate with some external log search and analytics tools as well. Okay? Yes, another question. It's running multiple instances, and your question is what?
So if the app is running in multiple instances, so how you can differentiate the log?
The logs will basically have enough information in there to show you which instances the log message comes from. It's a bit of a more involved answer, but maybe we can chat a little bit afterward, because we still have a lot of info to cover. Okay, all right, let me turn off and hand it over to Josh.
Thanks. So we've talked a lot about 12-factor and how you consume things from the environment. The environment also puts some requirements on you and on your application and how you build it, right? 12-factor is a set of axioms. One of the most important ones that seems really generic on the surface and in terms of requirement it is, you have to start fast. The reason you have to start fast is you can't do this list of things if you don't. Deploy, scale, release, and recover. The cloud's going to kill you most days, right? Hardware dies in AWS data centers. We'll shift VMs out from underneath you in Cloud Foundry, right? All kinds of stuff happens. So if your app can't start quickly, you're not able to recover from kind of just what is a normal day-to-day operation. You also have to shut down gracefully when you're given a signal, right? SIG term normally. You have to do this basically so you can start, right? If we look at kind of typical problems I've had in my career where my apps didn't shut down gracefully, I end up with things like locked jobs and databases. I end up with like database connections hanging, and then my SaaS database service is like, no, you have 50 connections. You can't have another one. You also start to lose track of where you are. So you have to take this kind of stuff into account when you build and design your apps. So that's kind of something to remember, right? You'll see that the app we have, even though it's basic, starts up fairly quickly. Even large Spring Boot apps tend to start up very fast, and as long as you're not loading a bunch of data from a database, say, before you expose a REST interface, you're fine. The other thing to remember about this, right, is 12-factor was written by a platform provider. Just like Cloud Foundry, Heroku gave you a PaaS. We have to make intelligent decisions about your application, and we can only do that in terms of starting with the concept of a timeout, right? So if your app doesn't come up in some amount of time, we've got to call it dead. So starting quickly is very important to have success in these environments. I think factor 4 is really the most important factor. It basically says that you have to access everything through the environment, right? Cornelia has showed us an example of this already where we greeted me through an environment variable. But this gets more complicated as we start to look at our applications and their real topologies, right? We have databases, we have message queues, and we have those databases and message queues in very different environments. So we have to have a way to take this one artifact, point it at different databases and different message queues every time we deploy it. And the way we do that is we access the environment through a locator. So Cloud Foundry has an environment variable called vcap services that we use to encode all of this information. Other systems will use different things. I know Heroku, for example, gives you a bunch of environment variables per connection or per backing service. The reason we do this, right, is so we can change the locations of those things. There's kind of a 3-step process here that we'll walk through, and then we'll look at the code to consume it. The first thing you have to do is create the thing that you need to talk to, right? So this is the Cloud Foundry command to spin up a new MySQL instance. For our example app, that's where we're going to store our information. This is a Cloud Foundry command which will connect your MySQL instance to your application. And the net result of this is you now have an environment variable inside of your container in your particular deploy that tells you where your database is. So you're going to have a JDB connection string inserted. You're going to have a username and a password. That last command is kind of a drag, right? There's a lot of ceremony, and if I have to run all these commands every time I deploy my application, one of two things happens. We forget to do things, and then we have unexpected results, or our CI systems get really, really complicated. Cloud Foundry has something called a manifest that lets us declare what our application should look like and how it should be deployed. So we're going to use that. We're going to look at the diff here for our code in just a second, and we'll see that we've kind of changed the way we deploy, and so the commands will have changed a little bit. The most important thing to get your head around at the very bottom is that services thing, where we declare that we're going to depend on a service named HelloDB. If that service doesn't exist, if we don't see that environment variable, our application will fail to deploy. And this is good, right? Because now our deploys will fail fast because backing services are missing. Oops. So I'll go back over here, and we'll look at backing. Oh. Sorry about that. Backing services. So the first thing to note, right, is the manifest. We just saw this in the slide. This is the same thing. Inside of our Gradle build file, we've made a couple of new declarations. If you've been to the Spring Cloud, particularly a Spring Cloud talk where they've talked about the connectors, this should look familiar. We're including a dependency on the service connection library, and then we're including a specific dependency on the service connection library for Cloud Foundry, right? I said earlier that platforms will expose these variables in different ways, or these config entries in different ways. This is the one that understands how Cloud Foundry does it. We've included two other libraries, and I'll go over them in their opposite order. We've said the runtime must have a MySQL driver in it, and we've also declared a dependency on Flyway. So we're going to push an application which needs a database schema. We're going to just let Flyway create that for us now, and we'll come back to why we let it do that in different ways we can manipulate it when we talk about the 12th factor. The other thing to orient yourself is we've made some structural changes to our service. Our controller now has a service injected. It's auto-wired, right? And then we've changed kind of the route. We've made it possible to pass a person to greet as a request parameter. Everything else is pretty much the same. We call our service, which does a save. We get the time that we greeted somebody, and we make a date out of it, and we save the name. This is backed by a Spring CRUD repository that comes out of Spring Data JPA, the really easy interface project, which you can see in right there, right? So this all looks pretty normal, pretty vanilla Spring app. This seems like it would work just about anywhere. So we'll go and we'll check out this app. We'll live on the edge and see if we need those commits. Sweet. So we'll go ahead and build this.
Josh, you want to delete the app that's out there, so otherwise you're going to share a route.
I'm going to do the blue-green to it. So Cornelia makes a good point. If we look at the apps we have now, we have our original app, and it's still up and running. It's not connected to anything, but it is known by a URL, right? Hello 12f.cfapps.io. For the rest of the presentation, we'll deem this our production URL, and we'll push our apps. We'll mess around with them to verify that they work, and then we'll cut over prod. So, right, this is how people will come to know our apps from the outside world. So the command has changed a little bit. I'm going to just, for safety's sake, make sure we clean up our environment, because I'm paranoid. So this command I've just run says trash my database, set our environment back to normal. I think we already did this, but I just had like kind of a scary thought, and I don't want our demo to fail. So I've asked Cloud Foundry to spin us up a new MySQL instance that we can then later bind to. This will give us an empty database. And at this point, when it's all done, we'll push the app up. So you can see a couple of things have changed in our output, right? We're pushing the same app, but the name has changed. So we'll have two instances of we'll have two different versions of our app running, essentially. It's created a random route for us because I didn't want to have to fuss with not finding a URL. So it just generated a bunch of random words after the name of our app for us. It's going to try to bring it up. In Flyaway, if you're unfamiliar with it, just kind of by default, if you don't do anything in a Spring Boot app, you declare the dependency and you just don't write any more code, kind of like most things. Just works and it has a default behavior. So we have a database migration that'll create a schema for us. It's a pretty basic table that maps to our class. We can see it in here. So we just create a table with 3 columns, an ID that's auto-generated, a date that says when I was, or whoever was greeted, and then the first name of the person we're greeting. This is specific, and we want to call that out because that's important. You'll see that when we talk about environments and how they should be the same. This is only going to work on MySQL, right? That schema create isn't going to work on another platform. That's different than how we've done things for a long time, right? But 12-factor is very opinionated that we should always work with the version and the type of service we intend to work with. I could have, to make my life easier when I was developing this originally, run H2 locally, but then I would have had to duplicate all this work. There's obviously other solutions to this, and I'm a pretty big fan of pragmatism. Do what works for you. But if we're going to follow the spirit of 12-factor, this is the guidance, right? We only interact with MySQL because that was our intention. So now our app is up and running, and we can curl it again. But we're going to have to use this new URL. Sorry, I operate Cloud Foundry more than I curl apps. So we curled it, and we see that we've added a default, right? We saw that the default value of people to greet was nobody. We can get a little more, formal. And we can greet Cornelia. We've also added a history API that'll just give us So we can see that we've greeted a couple of people, and we get some nice round numbers there, which we'll talk about in a little bit, as far as when we did that. So we've greeted 2 people at this point, and our app is up and it's running, and we've decided it's good. So let's go ahead and do the rest of this blue-green deployment where we make it so this app will respond to production traffic as well. So if we run cf routes, we can say cf map-route. I'll get the usage because I don't remember the command. We will tell it the name of our app and the domain that we want to add. And then we'll tell it the host name. So now something interesting should happen when I start to curl this application. We said before our default was nobody. So we should see, when we do this, the request will bounce between both apps. So the Cloud Foundry router routes randomly. We can see in the output there, sometimes it greeted me, sometimes it greeted nobody, right? So everybody believes me now that we're bouncing traffic between both instances of our app. We would go ahead at this point and decide to cut over, right? Our new version is good and the old one is bad, but we've done a 0 downtime deploy. One of the interesting things is we've actually made a really big functionality change to how our app works without our user ever seeing downtime. Yes, there may have been some things we had to manage on the back end, but our customer didn't see it. So we can say cf unmap route. Actually, we can just be a little more aggressive. Cf stop hello 12f. So we can see that the old version is stopped now. And if we curl, we just see the nobody records. We also note that our history API still worked. We're getting back JSON. So that's the takeaway, right? We've added a database, we deployed the app, and we didn't really do anything in the code other than say Spring Cloud, Cloud Foundry, and MySQL connection. Spring Cloud went through our environment, interrogated what was shown to us. If we look at the environment for the container, we can see that it injected a bunch of stuff that wasn't there before about our database, including the host name and the JDBC URL and all that other stuff. Where's the play button? Oh, cool, that works. So this is the takeaway from this section, and this factor is really important because it's foundational to making everything else work. Our code has to build with the knowledge of something, right? Our code built, in this instance, with a lot of help from Spring, so we didn't have the down and dirty of what the environment variable was called. Had we looked at Python, or had we looked at Ruby, or something that had a little bit less Cloud Foundry magic behind it, we would have seen very explicit, I need a variable called vcap services. In this case, Spring Cloud took care of that for us. When we staged our app, we built that stuff into the release. So we knew that there had to be a thing called HelloDB in the container. And when we built that, it's called a droplet, the thing we deploy, we shoved all that stuff in there. So all that information was available to us from that point forward. When we went to run the app started and it looked for a thing. And it found a thing by the name of HelloDB, and it pulled out the credentials, and it was able to communicate with it. So that's really the whole point of Factor 4, is you have to talk to backing services by consuming them from the environment. If you do it another way, you're not able to move around, right? I could take this application, and I could deploy it into another space, our production environment. So if I say CF target, do you remember what it's called? 12-factor. We can see in this space I have no apps. I do have a service, so I'm going to push our app again. So I haven't changed anything. I'm not rebuilding anything. I'm going to spell push right. And we'll watch the app go up, and we'll see a new random URL that gets is generated for us. So our app is a different instance. It'll respond on a different location, and it'll talk to different data. So in a minute, when this comes up, we'll be able to see that the database is empty. But the reason we do this, right, is so we can deploy to multiple places for different reasons to make life easier. We'll talk about what that enables in just a second here when this comes up and I prove to you guys that it works. Actually, let's start to talk about that while this goes on. So the next factor is dev prod parity, right? You can see where I'm going with this. Production and staging should be the same. Similar is great. The same is better. We've all, in our career, spent a lot of time screwing around with, oh, the prod box doesn't look like my non-prod box, or, well, I develop on a Mac, and I spin things up inside of Eclipse, and then I wonder why it doesn't work when I ship it off to wherever my code goes, AWS, whatever, right? These are problems that it's undifferentiated heavy lifting, right? We just waste a lot of time doing stuff that shouldn't happen. This is way more important when we start to talk about cloud-native apps, because they're designed for to be continuously deployable. So if we got to go through all of that ceremony of verifying that, like, I checked it in and it worked on my local box and then it worked in the staging environments, it's a little bit different. And how are we ever going to know it works in prod, right? This parity becomes really, really important. It lets us go fast. So we have, in the environment that we're working on today, we have effectively a CI environment and we have a prod environment. Usually there's another step called acceptance with the workflow we use at Pivotal Labs, where somebody will come and they'll bless a particular commit. But by whatever process you follow, you'll make commits to your source code and you'll make changes. And eventually you'll decide, or as a team or however you do it, that we have one we want to look at and this content is exactly what we need and we should be ready to go. Mr. Product Owner or Product Manager, do you want to deploy? They'll make the call and they'll say, yes, this is how it works for us. So we deploy version 2.01. And now that app is live, but we didn't do anything additional to it, right? We just ran CF push and it was out and it's gone. The reason that works is because there's parity with all these environments. They all have their own values for environment variables, but they all use the same environment variables. This lets us go fast and it's repeatable, so we can do it over and over again, and every commit becomes a candidate for a deployment. So our operators, should a need arise, can come back, this is a really good need, right? They can come back, they can patch the platform, and they can redeploy software. So there's a lot of power that we get by leaning on the platform and relying on the platform to be the same. That makes sense to everybody? Any questions? So as we go back here, our app is up and running, and we can do, not CF curl. And we'll see that greets nobody, and if we look at the history, we only have one entry. So right, use a platform. It's the same because it's the same. It takes all the guessing away. We already did that. Factor 12 is my least favorite factor. 12 factor was written with an opinion and a bias towards apps that ran with REPL shells. So when you look at admin tasks, this becomes very, very obvious. Where somebody's like, hey, I can spin up a shell, and I can SSH into this thing, and I can kind of do whatever I want, because I've got this really great free-form kind of plug-in way to interact with my environment. We don't have that in Java, right? That's just not a thing for us. So we have to treat this factor a little differently. The spirit of the law says admin processes run against a release. We can totally do that. Our tools are geared to do that. It should run in an identical environment. That's totally fine. It should use the same code base and same config. I think that makes a lot of sense. It's weird because it looks like something we've been telling people not to do for a long time. But in kind of advanced cases, you end up with these multi-project Gradle files, which feels a little wrong. Every time I do it, I'm like, that's not right. Your admin code should absolutely live with the code it administrates on. That's why we end up in these multi-project situations. The thing I want to call out is this has a lot of rules. Be pragmatic, right? Do what works. That's the most important thing. I got wrapped around the axle by this last week, right? We had a lot of talks about the 12th factor and how much it was pissing me off to do the right thing. To the point where like I stayed up till 2 in the morning before this trying to make it work, and I was finally like, forget it. Oops, too far. So we're going to grab a new version of our app. And that app is going to have a small change. I talked earlier about this date didn't have much fidelity. I'm going to go back to the other space so we can use our nice URL. So we'll build that, and then we'll kick off the deploy, and we'll look at what's different. Sorry. So if we orient ourselves again, there's nothing different in our build file. We still depend on the same stuff, right? Flyway's still there. We've done one kind of new thing. We've decided that the fidelity we were getting out of the time we greeted somebody was not very good. The way we set up the database originally, it was a date column, and all it stored was a date. So when we did our history API, you saw we got the same number every time. It's because it was midnight today. The product manager said they would like better. So we've gone and we've made a small change, which I think is probably easiest to see if we just diff it against the last branch. F4. So before, we had a date. Now we're using the Unix epoch seconds. And then we can see the way that change has trickled down to through our code, where we've started using a long instead of a date. Right, all the way down through to our entity class. We've also had to create a new database migration for this. I picked a weird example intentionally. I wanted something that MySQL would choke on if we did the wrong thing. We create a new table. We give it a temp name. We change the layout of that table. So initially, it will match the exact same columns as the greeting table. So we alter it to just take a big int instead of a date. We grab everything and we do a transform so it matches the format we expect in the new table, and then we copy the old one to a backup because we probably don't want to lose the old stuff in case something goes rogue in this process. And then we copy the temp table over to a new table. So this is awesome, right? My app can do this. What sucks is I have to take downtime because it's a database migration and it's a real one. So earlier, Cornelia's version of the app and my version of the app could run because we didn't share a dependency. Now, if I was to push to a new application, we would share a dependency and we would have a problem, right? There would be some sort of conflict. How it manifests itself, who knows? I think what really happens is we would end up corrupting the database, and then none of them would work, right? In the real world, that's absolutely what happens, right? For our trivial app, we might get away with it if there was no request coming in. So what we're going to do in the simple case is just have Flyway run the migration for us, right? The way Flyway works is it looks for files with certain naming conventions. So on the class path, it looks in DB migration, and if it sees something called v1, it runs that, and then it sees something called v2, and it runs that, and it just so on and so forth in order. So it's going to run during the push for us, during application startup. It's going to migrate the table for us. So we'll see that our app is up and running now. And if, the demo gods are smiling, we'll see what we had in there before. Big thing to notice here, right? We ran curl against the thing a whole bunch of times earlier. The times are all the same. So if we were to add a new person, if we were to greet somebody new, my boss left the back of the room, so we'll use his name. We can now see that we've got a time with a little bit more fidelity, right? So that happened all on the fly. We ran our admin process. It happened in the container. It happened against the same config, obviously, because we manipulated our database. And everything was good. When you can do this, I would say do it, right? That was really easy. I can take downtime. Life is good. We could have gotten super crazy about how we managed the database and done the migration on a snapshot and brought that back and reconciled the differences. So there are ways to solve kind of zero downtime problems with database migrations and admin processes. They're just a lot of work. So rule number 1 about factor 12, if you can take downtime, take downtime. Moving forward, though, things get more complicated, and sometimes you do just want a separate app. In the GitHub repo, and because we're running short on time, I'm not going to cover it, there's an example for how we would do this, and basically we just move all the Flyway stuff into another app and build it as a multi-project build. So that is the end of my section, and we're back to Cornelia for port binding.
Okay, cool. Turn back on. All right, so we just have a couple more to go through here. One of the first things is that we're going to talk about is factor 7. So again, you can see we're going out of order here. And really the punchline about port bindings is that let the platform handle that for you. So one of the challenges as you're moving things through the application lifecycle, or if things are changing even in your prod environment, is if you're having to change ports and you're having to go in and change some configuration somewhere, and oh my gosh, this is running somewhere else and I have a different URL or I have a different port, you have to handle all that port stuff yourself. And so really the whole point here is that allow something like the platform to handle that for you. And the cloud native application platforms, remember that was the quote at the very beginning, are designed to do exactly that. So let's go ahead and take a look at that. Let's see. OK, you're at that URL. Great. I just wanted to make sure. So let's do git checkout on factor 7. Port bindings. I'm going to do a build. And then we're going to go ahead and deploy it. And then I'm going to jump over to a picture while we're waiting on the deploy. CF push. OK, there goes the deploy. So let's go back here and take a look at a picture then. So here's what happens in Cloud Foundry. So what I have is I have a number of different machines out there that we're calling runners. Those runners are, I talked about it as an implementation detail, but the implementation detail is here that they're creating containers, and my apps are running in containers. So in this picture here, you see two different runners, which are two different virtual machines. They're each broken down into different containers, and you can see that those are running. And the way that port mappings happen is this. When we go to hello 12 factor, it goes into a routing component that's part of the platform. That routing component has essentially a table that it maps to, and it says, I see that hello 12 factor is mapped to this application instance that's over here. And it's mapped down to a URL like 192.168.200.27 and a port, okay? And that port is written. And I'll show you what the difference, we're going to see this in the code in just a moment. And it handles that port. You'll notice that I never configured, I never said port 61021. I never gave it a port, but that's all handled for you. And we'll get back to this picture in just a moment. I can have multiple instances, and in fact, I'll point it out right now. You'll notice here that I've got two different runners. They have two different URLs, 192.168.200.27 and .33. But the ports are locally scoped. So I might, in fact, have the same port number running on two totally different machines. Now, imagine if you had to manage ports across an entire distributed environment of different virtual machines. That would complicate the matter even further. So don't go there. Get a platform that does this for you. So let's come back here. Great, things deployed just fine. So I'm going to go ahead and I'm going to curl this. And you'll see that what we've done in this application is we have, I don't want the history. I just want this. What did I do? Oh, there we go. 12, I was going to say, are the demigods not smiling on me? Okay, so now you can see here that it's greeting nobody. And here's the IP address of the machine that is running that application. And I can curl this again, and you can say, see, here's the port numbers. And it turns out that there is a facility here in Cloud Foundry that allows you to actually have set the port internally, and then it maps to an external port. So you do have the best of both worlds, that you can do some of that configuration yourself, and we'll take care of the port bindings for you, so that mapping. So I can keep curling this and keep curling this, and I'm always going to get back that same IP address and the same port. Now, let's get back to the next factor. And the next factor is about stateless processes. So when you're deploying your applications up there in the cloud, here's what your cloud looks like. In the beginning, you might be running on one machine. And then things are going better, and you need more load, and you add additional machines. And then all of a sudden, your app goes viral. And you need to scale out to tons of instances. So you've deployed now 10,000 instances of your application because your hello world is so freaking cool that everybody's looking at it, right? Well, if you look at an environment like this where I've got hundreds or thousands or tens of thousands or maybe hundreds of thousands of machines, something's breaking all the time. There's always something going down. And I can tell you that when you're Google searching, there's machines going down all the time, but it still keeps working. I can keep going back, and I can get my search results, and I can go from page 1 to page 2, and you know what? A machine may have died. The machine that I was just getting my response from may have died in the process. And so the whole point here, and this factor 6 is all about designing for failure. That's the why of it. And so what the statelessness does is if you stick with stateless apps, it allows the platform to do all sorts of things for you. So let's take a look at that. So I'm going to, I probably should have put this, I could have saved myself a little bit of time, but we're going to do a checkout of the next factor, and we're going to do a Gradle build, and then we're going to deploy this. CF push. All right, and so what we're doing now is I'm redeploying that app. You'll see that the change that I made in it Actually, I just added another endpoint. So I'm going to simulate one of those explosions in one of the machines. So I'm going to simulate my application dying. And I want to show you something. It relates back to the port bindings. And I'm looking at the clock. I realize I only have about 2 minutes to go, which is, we're going to make it. We're going to make it. Stick with me. Except for the deploy always takes just a couple of minutes. But once this comes up, you'll see in just a moment that I've simulated, as I said, I've simulated this application dying. And there's something very, very interesting about that because it comes back to the point about port bindings. So the port bindings, remember I said things are changing, maybe the ports are changing, and we're going to see an example of that in just a moment. And if those things are changing all the time, you don't want to manage it yourself. Today, to live in this cloud-native world, you absolutely have to automate everything. So you cannot manage your applications and your deployments and your upgrades all by yourself anymore. You need to have some help, and that's where a platform comes in. Okay, so if we now curl this, you can see here that my app is up and running. I'm now running on 10.10.81.16, port 63685. So I can keep doing this. And now in this particular case, though, I'm going to access a new URL that I have in my app, which is this broken URL. And you'll see that I got back some JSON that I wasn't expecting. Okay. I'm hitting both. CF apps, your version of the app is Hello Spring 1. CF delete. That's right. We're load balancing over that. Delete, sorry. Hello Spring 1. That's what I thought was going to hit you earlier, but then you did the blue-green instead. Okay, so let's do the curl again. And there we go. It says, something's broken. Now, if we do a CF apps, we can see that at the moment, only 0 instances of that one application. I want one running, but the one is not running anymore. So if I do a CF apps, and I'm wondering whether the demo gods are not going to smile on me, it says requested state is stopped. CF restart. Hello, 12 factor. Did I kill the wrong one? This should only take just a moment. The requested state was stopped. So what I needed was the requested state starting, which is why it's not there. And I know I'm over. I promise I'm finishing up here. I just killed it. Okay. So no, I'm deployed to the wrong application. So I'm just going to go ahead and close out. That's how you know it's real, is that the demos don't always work. I'm happy to show this to you on a break immediately following. So the final factor that I want to talk about here is concurrency. So we're all familiar with the scale up model. So if you need more and more capacity, you just give it more memory, or you give it more CPU power, and so on. In the cloud native world, you scale out. You build your applications in such a way that if my Hello World app goes viral and I need more instances, I just deploy more instances. It's very, very simple. That's the way it works. So what we have here is we've got a bunch of different workloads. And by the way, those workloads aren't just web apps. They might be background processes. It might be different process types. And when you scale out, you're just going to scale out additional instances. Now here I was going to show you a scale demo, and I was going to show you how quickly, and one of the punchlines is I was going to scale from 1 app instance to 5 app instances, and it literally happens that additional app instances start up in about a second. And remember all the way back to factor 5 where we split out design, build, release, and run, and we said release bundles everything up so that run can happen very quickly. That's what the platform does for you. So that release process allows you to scale to additional instances, and I won't have the time to show you that demo. Last couple of things, that's not all. We have some additional bonus factors. We do want you to think about auditability of your applications, and it's not just your responsibility. In fact, that's another thing that as the developer you can push onto the platform. So having the platform provide auditability, what's running where, when did it start, all of those event streams and so on, and that's already part of the Cloud Foundry platform. The other thing that you need to think about is you need to think about writing applications in such a way that you can external from the application apply authorization and authentication against those. So role-based access control against URLs. That's the important thing, is against URLs. And in fact, a couple of these come from our colleague Josh McKenty. We were just having this debate in the last week. So thank you very much. We'll leave you with just a couple of things. We can recommend a couple of upcoming sessions. So there's a Spring Boot for DevOps. So a lot of what we've been talking about here is DevOps-ish. So Spring Boot for DevOps, there's a presentation happening immediately after the break at 10:30. The other one that Josh was talking a lot about, Spring Cloud, there's a Spring Cloud Services talk this afternoon at 2:30 that Scott and Craig are doing. I strongly encourage you to go take a look at that. It's going to give you a really good idea about how some of these factors are implemented in the Spring context. And I already mentioned the Migrating the Monolith. And there again is the URL of the repository that has all of the examples that we just showed you. And we'll stick around for a little bit if you have any questions. So thank you very much for your attention.